application. My name is Gunnar Grosch. I am a senior developer advocate at AWS. Today, I want to talk to you about how we can verify that our serverless applications behave as we expect them to. I'm going to do that by showing what verification is and how to do it. And I'm going to show you several practical examples of verification for serverless applications. So this is a statement from the updated reliability pillar of the AWS well-architected framework. Testing to ensure that you can meet your availability goals is the only way that you can have confidence that you will meet those goals. And what this tells me is that even though we follow best practices, for instance, by using the well-architected framework, and we use services that are built for high availability, and we are really good at what we do, well, building modern applications that often are distributed by default, it is really complex. So we can't really gain that confidence in the application until we've seen how it behaves under adverse conditions. So we have all of this complexity. How do we keep moving fast and not break things? And we as an industry, we are usually quite good at reactive measures, like incident response, disaster recovery, and different testing methods like unit tests and integration tests. But verification, that is a proactive experimentation where we're able to verify system behavior. So verification tells us why it's important to explore different set of conditions and the impact those conditions have on something that we care about. So let me show you. First, we have the objective, and that is something that you care about, something that says that your system is available. For instance, page loads, number of clicks per second, processing speed, and so on. Different things that you care about. And the objective might be defined at a business level. For instance, I want 10 items added in cart per second. Or it might be a technical and tied to a service. Like, for instance, my purchase API should respond in less than 400 milliseconds. And the objective that we set, it of course need to be measurable. So we might, for instance, track the number of items that our users add in the cart per second. And we then add 10 as a threshold. Or instead, we measure the purchase API and we add the latency threshold we defined earlier, 400 milliseconds. And then we have the conditions. And the conditions reflect different type of events that could occur in our system. So what if there is additional latency to each API call? Will the API still respond in less than 400 milliseconds? What if there is a downstream service error? Will we still get 200 clicks per second? We often know how our application behaves while we're in the steady state, that is the normal operational state of our application. But adding these conditions, that's to show how the application behaves under adverse conditions. And with the objective, the measures, and then one or perhaps several conditions in place, we can then verify our system behavior. And looking at this from the perspective of a site reliability engineer, perhaps the objective then is the SLOs and the measures are our SLIs. And the conditions, well, they are different type of events that could occur and could affect our system. So let's look a bit at these conditions. As I said, conditions, they reflect different events that could occur in our system. And this is where the chaos engineering part comes in. I can't really have a talk without talking about chaos engineering. So we can now add our chaos experiments as a condition to our system verification. And when we're working with verification, we're adding these conditions as a way to learn about how our system behaves. So it's really not about breaking the system. It's about learning, and it's about building that confidence, the confidence we can only gain by testing and learning how our application behaves. So let me show you some examples of conditions we can add. We have a very simple serverless application. It's a web service with an API gateway, a couple of Lambda functions, and that are retrieving or storing data in S3 and in DynamoDB in this case. And we have an S3 bucket that the client uses, for instance, for fetching static data. So we can then add errors, inject errors into our application. And that might be, for instance, errors that makes our application return an error code instead of the normal 200 response the client would get through API gateway. Or it might be that we're causing exceptions in our Lambda function to see how our application behaves then. We can create different type of errors that are security related by adding security policy errors, and different type of service configuration errors. And these are errors that we every now and then might introduce when we're deploying, when we're creating new features. So we can create these as conditions as well. Or if we're using the disk space in our Lambda function, for instance, to manipulate data or using it as cache of sorts, well, then we can introduce disk space failures as well by watching how our application behaves if the disk space is full, for instance. And we can create different type of downstream service issues. In this case, we have S3 and DynamoDB as downstream services, but very common is to have an API, a third-party API as a downstream service. So we can add different type of issues to those as well to watch how our application behaves under those conditions. We can, of course, create issues in regards to concurrency and different types of throttling as well. And then we have the primary or the most common experiment or condition to add, which is latency. We can add latency to our functions to, for instance, simulate how cold starts affect our application, or different type of runtime or code issues. Of course, we can add latency as a way to test integration issues. Once again, that third-party API, if we add latency to that. Or we can use it as a way to test our timeout values. The timeout values of our applications, they're usually okay while we're in that steady state, but what happens if we have issues, for instance, latency in our application? That's a good way to test those. And to create these conditions, we have some tools that we can use. And the perhaps most common ones are these: Chaos Lambda, which we can use with our Python-based Lambda functions, and Failure-lambda for our Node.js-based Lambda functions. So let's just look at how Failure-lambda works. So it is an npm package for our Node.js Lambdas, and that we can easily install. And we configure this with the help of either parameter store or AWS app config. We then have several different failure modes that we can use. We can, for instance, add latency. We can create different type of status codes to, instead of returning a 200 response, we can return a 502 or 404 or other types of errors. We can create exceptions within our Lambda functions. We can do these disk space experiments, or we can use a deny list as a way to intercept and then deny network calls to downstream services, be it AWS services like DynamoDB, or perhaps more commonly use it with our third-party APIs to see how our application behaves. And it's fairly easy to get started with. We wrap our Lambda handler with it, and then we're good to go to use it. And then we set up the configuration for it, which is done through basic JSON syntax, and as I said, stored in the parameter store or by using AWS app config. All right, so back to our verification process. So we now know a bit about how we can add conditions to the process. So let's look at some practical examples of verification. So in this example, we have a simple serverless web service. It's a client calling API gateway, which in turn invokes a Lambda function who retrieves or stores data in DynamoDB. So first off in the process, we have the objective. And the objective in this case is my purchase API should respond in less than 400 milliseconds. So business or a technical metric in this case. We then set a measure, basically set up 400 milliseconds as a threshold, and use that as a way to measure if we are following that objective. And we then add our condition. In this case, we're going to inject 100 to 200 milliseconds of latency into our function. So for each invocation of our Lambda function, we will get an additional 100 to 200 milliseconds of latency. And then we're able to verify that part of our application. We can then verify to see if it passes verification or if it fails verification. So that's one example of how we can add conditions to our verification process. And in this case, by measuring the purchase API. Next one, we have the same simple serverless web service. And in this case, we have a business metric. I want 10 clicks per second for this web service. So we set up a measure, 10 clicks threshold. We, of course, need to be able to measure our clicks and then set that metric. And in the condition in this case, well, let's inject a downstream service error into our application. And that might be on each invocation. It might be on just parts of the invocations, and then to test how our application behaves. And in this case, perhaps more importantly, see the user behavior based on that condition that we add. So then we're once again able to verify, did we pass or fail our objective when we added the downstream service failure into our application? So those are two different examples of how we use conditions as a way to verify our system behavior. So the question then is, where should we do this verification? Well, you don't have to do it in production. Just to be clear, you can do it in test, you can do it in dev environments, you can do it in staging environments, and so on. The more production-like, of course, the better. But many of these tests, they are great for verification of behavior even in test environments as well, to see that we've built the application in the way that is according to best practice. We have different type of graceful degradation and so on. We're using queuing and so on. All right. So we've now looked at verification, and now I'm going to look at part of an evolution that we're seeing from CI, continuous integration. CI limited the number of bugs that we can create by merging code faster. So the bugs that we do create, they become more apparent, and they don't geometrically lead to larger number of bugs. So the engineers can now create features faster. All right, so now that we can make software faster, that involved into CD, continuous delivery. We needed a way to get our features into production faster and to be able to roll forward faster. And the next step from that then is to do the type of verification we just looked at, but in a continuous way. With the type of complex systems that we build, we need to have this as a continuous process to be able to verify our application as we're delivering new features to the application. And that's what we call continuous verification, or CV for short. All right. So with the same simple web service we had before, we're now adding on our delivery pipeline. In this case, we have AWS code commit, code pipeline, and code deploy. That's a fairly standard way of delivering code into our serverless applications. But you could, of course, use any type of CI/CD platform for this. And instead of inventing this as a new type of service and adding it somewhere else, we can use this process, the ones that we usually already have in place, and add the verification to that. So let me show you an example. In this case, it's the same basic web service, but with our CI/CD pipeline in place in front of it. We have the same objective. The purchase API should respond in less than 400 milliseconds. We set our 400 millisecond threshold as a measure, and we then add our condition. But instead of doing this as a one-off manual process to add this, we're adding it as a step in our deployment process. So the experiment or the condition, that's added there. So we're enabling this as part of our deployment, and we're then measuring the result of that condition added to then be able to verify the application during a set amount of bake time that we're waiting for the result of our verification. In this case, it passed verification, so we're then disabling that condition, removing that, and we now have a new feature that is verified, delivered to our users. Let's look at another example. Same pipeline, same web service. And we're using the same objective, respond in less than 400 milliseconds. We have our measure in place. And now we want to add our condition. But the blast radius of the condition we did before, it's quite large because we're adding that condition to all users. Now instead, let's add it as a canary deploy. So instead of having that condition on all invocations of Lambda, we can add it to, for instance, 10% of invocations. So 10% of invocations will get that condition added, and we're then able to verify on that smaller blast radius if our application behaves as intended. In this case, it's a latency that we're injecting, but think about all of the different conditions that we could add in our application. And having that on a smaller blast radius means that we're able to see it without actually affecting all of the users in the platform. In this case, verification failed. We saw that users weren't getting a response from the API within less than 400 milliseconds. So instead of continuing with the deploy, we're rolling back the deployment. So users will continue using the older version or not the new feature with the condition added. So a third option as well. This is perhaps my favorite. So same service, same pipeline. We have the same objective, still want to have the purchase API respond in less than 400 milliseconds. We set up our measure, and we add the condition. But in this case, we're going to do it with the help of feature flags, because using canaries means that even though we have a smaller blast radius, we don't have control over which users will get that condition added. Because we have a stateless application, we don't control which of the 10% will get to Norway or which will get to Sweden and so on. But using feature flags, we're able to then enable these conditions on specific users, for instance. So if we want to add this condition to users from Norway only, well, we're able to do that with enabling it as a feature flag, but still as part of our delivery pipeline. So it's a continuous verification of our application. In this case, when we've done our verification, we've seen that it passed. So that's great. We can then remove the condition, but keep the new version in place. And then we have new users rolling over to the new application. All right, so some key learnings from this. Pretty quick overview of continuous verification. Verification tells you why it's important to explore a set of conditions. And it's really not about breaking things. It's about learning, and it's about building confidence in the system. And it is quite easy to get started. We don't have to look at chaos engineering and continuous verification as this big obstacle to get to. We can get there quite easily. And I want to leave us with this. Testing to ensure that you can meet your availability goals is the only way you can have confidence that you will meet those goals. So today we looked at how we can verify the behavior of our serverless applications through verification and by adding conditions. And this allows us to learn, build confidence, and in the end, create more reliable applications. My name is Gunnar Grosch, and thank you very much for joining today. I think you're muted, Samira.
Oh, thank you so much, Gunnar. Thank you so much. I'm so sorry, guys. I'm having some problem with the systems and I was not able to join. So thank you so much. Excellent presentation. I really enjoyed. And we lost this the first part. I wanted just to thank everyone and to welcome to our session of Amazon and AWS Communities Hero. So but before go to that, I want to ask you only two questions. One question is about So when should we start thinking about using verification for our application?
I think it's something that we should start thinking about quite early on in the process. Building applications that are as complex as many of our applications we build today are means that we need ways of knowing how it will behave. So I think thinking about adding these perhaps not continuous verification, but at least verification of applications early on, I think that's a great way to make sure that our application behaves as it should. Think about the scaling that you might get in your application when you're adding more and more users. So adding it early on, I think that's the way to go.
Oh, that's a great answer. Thank you so much. And I have another question also. So how much added time and effort it is used for the technique in general?
Well, if you add it as part of the day-to-day work, it shouldn't really be that much added effort. If you have it as part of the way you deliver features today, it should be a smaller addition to the work you actually do. And thinking about it as a proactive way of verifying applications means that instead, perhaps you'll remove the part where you have to spend time fixing failures, fixing bugs, and so on instead. So in the end, hopefully you'll save time by doing it.
Okay, that's great. Thank you so much, Gunnar. I don't see any other question in the chat. It was definitely a great presentation. I really enjoyed and learned new things. So thank you so much.
All right. Thank you very much.
Thank you.